Right, let's see, full screen, lesson set, I believe 23, but I'll check it before I put it on the channel. I got just enough time to do this, so I'm gonna kind of rush through it. X minus 4 times x gets us x squared, minus 3, minus 4 minus 3 gets us minus 7. Multiplying the constants get us 12. How do we get from 12 to 3? We go down 9 and divide by x minus 4. Okay. How do we check if that's right? The critical number here is 4. I could have easily put the minus 9 outside. And if I picked 4, then that becomes 0 times anything is 0 gets us negative 9. If this is indeed correct, then over here a 0 has to get us negative 9. So I'm sorry, 4. I made the 0. So 4 is 16 minus 28 plus 3 is 19 minus 28, which is negative 9. So we move on. We know we're correct. You don't have to ask me if it's right. You know it's right. Next problem. Let's get Rene Descartes going here. Okay, Rene, let's get you around the corner. There we are. And we are looking at kind of a multi-task, multi-step problem. So rewriting it gives us x squared equals x plus 6. X squared minus x minus 6 equals 0. Factor, you get x minus 3 times x plus 2 equals 0. Bases of exponentials from the last lesson set have to be positive. So we discount negative 2. 3 should work. Let's see if 3 does work. Put a 3 here and a 3 there. And it sure does look like 3 squared equals 9. Push on. Cube roots. Any exponent divided by 3 is a perfect cube. For instance, x to the 6 over 3 is the cube root of x to the 6th, and that is x squared. 3 goes into 6 twice. So 64, we want to make sure you know 8, 27, 64, and 125. Those are the user-friendly cube roots. They have nice cube roots. 64, the cube root of 64 is 4. 3 goes into 8 twice, so I can take 2x squared out. X squared cubed is 6. I need another 2 inside this cube root. Don't forget the cube root. So I know that x squared is the remainder when I take this out. Y, z to the 7th. Again, 3 goes into 7 twice. So I can bring out z squared. 2 times 3 is 6, plus 1 more is 7, so that's done. All right, point of inflection. Minus b over 3a is the average of the roots. And that's where you get a point of inflection from completing the cube, which is in the cubic playlist. If you want to look at completing the cube geometrically, I think you should. So therefore, what do I have? I have minus 12 divided by 3 times 1 is 3. Oh, I don't usually make you work that hard, but I did here, I guess. So that's minus 4. I think I changed that to 6x squared on your end. I changed it to 6x squared is what I did, so that you didn't have to work so hard. But I forgot to tell you that. So you got to work hard, sorry. So minus 6 divided by 3 is minus 2. That would have been easier to work with. So minus 2 cubed is minus 8. This should be 3 times that and the opposite. That relationship exists. Minus 2 squared 4 times 6. Yes, that's true. Minus 2 times 10, minus 20, and minus 5. Okay, I hope that's what I asked you. If not, you're getting a practice on a new problem. All right, because I was running around quite a bit before I had to get this thing printed and an answer key made and so on and so forth. So I may not be doing the same problem you did. So this becomes twice that and opposite. Minus 25 gets us minus 41, I believe. So what was the point of inflection? Point of inflection was negative 2 minus 41. And the graphing form for this then would have been 1. You don't have to have the 1. X plus 2 squared cubed, done too many quadratics in my life, cubed, x plus 2 minus 41. And the only thing you're missing is the multiplier there. That's all you're missing. And then you got the graphing form. All right, move on. Oh, you want to know how to get m? Oh, m is equal to c minus 3ah squared. C is 10, a is 1, h was minus 2 squared, and that's 10 minus, looks like 12. Looks like we're going down at 2 to 1, which means that I'm not going down for long. You got a function that looks like that. And at -2, -41, you got that point of inflection. Let's move on. So this problem here, I'm hoping you can look at from a graphical perspective, because sometimes we get extra answers. How do we get extra answers? Let's see. That only has one answer. But if I square both sides, then I could get two answers. But both answers don't work in the original equation. So when you square things, you might get an extra answer. So be careful. And I would prefer you to know if you get an extra answer from a graphical context. 2x plus 1 minus 1/2 is the critical number, and I'm going up twice as fast as I normally would with the square root of x. I'm going up twice as fast. So where's the y-axis? Pretty close to minus 1/2. That's where 0 is, and I'm at -1, and I'm going up. This is one that only has one answer. So when I square this side, I get 2x plus 1. If you square this properly, you get x squared minus 2x plus 1. I set it to 0, and I get x squared minus 4x. The 1's cancel, so I don't have to do that. So I get answers at 0 and 4, and only one of those works. I don't think the 0 does. No, I don't think so. I don't think that that branch exists. No. So just x equals 4. 4 plus or minus 2i. What did it come from? And this is what I write. YKTD. You know the drill. All right, so we're trying to get ax squared plus bx plus c equals 0. Trying to get a quadratic that has that as answers. 0 means nothing on the right side. I'm going to move everything to the left. And I'm going to square. So x minus 4 equals plus or minus 2i, running out of ink. X squared minus 8x plus 16 equals 4i squared. That's -4. So x squared minus 8x plus 20 equals 0. That's what I'm hoping I'm seeing. Let's see if this marker works over here. I'm running out of ink. I think it looks good. We'll find out. The cosine of A, and I gave a triangle that looks like this. There's x, there's 7, there's 10. What's x? I hope you can see the square root of 51. So what's the cosine of A? Square root of 51 over 10. That's it. What did I do? I knew that was 49. I knew that was 100. So I did 100 minus 49, which makes this 51. Doesn't look like it's drawn to scale very well. So that's the square root of 51. Cosine is adjacent. Well, this is the adjacent side. That's the opposite side. That's the hypotenuse. Adjacent over hypotenuse. There it is. All right, so let's keep the y's together. Let's keep the x's together. Let's make an exponential function. Let's do the x's first. x1, x2. I'm seeing x minus 2,000 over 24. And I'm seeing an exponential function. So let's do the exponential work. Hope everything's getting captured here. Not sure why that was there. Anyway, so I think the most important number here is 5. And I think I got to know how to get to 5 to 20, and I think that's up 15. And the next time, I don't think I'm going up 15 because I want to be 5 to 35, which is 30. Looks like the base of my exponential function was a 2. And it looks like the answer was 5 plus 15, 2 raised to the x minus 2,000 over 24 was the function I was looking for. I think this is running out of ink. Doing a lot of work here. So I see a V shape that's up. So that means I'm going down on the left and up on the right. Okay, so I think that's minus 2, x minus 1 plus 3. And I think at x equals 1, the absolute value of x minus 1 is where I don't get a sign change anymore. I think if I put a 0 in, I get positive 1. And I think if I put 2 in, I get positive 1. This thing seems to be hinging at x equals 1. But I'm going down on this side of 1, so less than 1. I'm going up on this side of 1. And one of those has to have an equal sign because 1 comma 3 exists. We'll put it there this time. Doesn't matter. So I'm going to subtract 3, 18. I'm going to divide by 2. I'm going to take the absolute value plus or minus 9. And I'm going to measure that from 1. So what are my two answers? One of them is 10. And the other answer is 1 minus 9, negative 8. So I'll put those on a number line. 10 minus 8. And I'll see what works. When I put 10 in, I get 21. Is 21 greater than 21? False. Negative 8, for the same reason, false. If I put a number bigger than 10, I'm going to get an answer bigger than 21. Bigger. Well, that's true. And I know these alternate. And you can plug in numbers and prove that to yourself. So the answer here is negative infinity to negative 8. And I'll use a parentheses. If I had an equal sign here, then it's a bracket. Okay, but right now I don't have the equal sign. So it's a parentheses, union 10 to infinity. I'll put it here. All right, moving right along. Let's get by the chair there. Let's park Renee over by the chair. Parallel park. We're good. All right, so what do I do here? Inverse operations. There's 10, there's 2, there's e to the 2, and then there's e to the 2 plus 3. I know that's 7 something, I think. 7 plus 3, so I'm near 10-ish. 10-ish, something like that. All right, so that's that answer. All right, let's do this. Let's take the square root of 9, which is 3. Let's cube it, which is 27. And let's put a minus sign, which reciprocates it. Now, how did I know that? I start with 9 to the x equals, let's get rid of this. So it's not in our way, our intellectual way. 127, I know, is 3 to the negative 3, cutting to the chase. So 9 to the x is the same as 3 to the 2x equals 3 to the negative 3. And I hope you can see that 2x equals negative 3 gives us an answer of minus 3 halves. I know what that 3 means, takes the cube root of 64. Well, that's 4 to the negative 2. And I know that's 1 over 4 squared. So I hope you're writing 1 over 16. Most of you are. How do I solve? 16 to the x could have been written as 2 to the 4x. 8 could have been written as 2. Well, let me do that out. All right, so this one I already did. Maybe it's a... Huh. Oh, no, did I do it for you? Yeah, I did already. So that was out of turn for some reason. I've got it written over here for, oh, that was to let the class know what the problem was. I forgot to put it on the test. Okay, I'm back and running. 16 to the x is 2 to the 4 to the x equals 8, which is 2 to the 3 raised to the 2x minus 4. I'm after the exponential activity here. That makes these equal. So therefore, 4x equals 6x minus 12. So 2x equals 12. Looks like x equals 6 works. What's the inverse of this? Well, this will kick out an output when I put something in for x. And that output is what x represents. So I'm really solving an equation here. So if I solve this for that output, the first thing I would do, because we're building this as a function of x, I would divide by 2. Then I do the inverse of e to the, which is ln of, and then I'd add 4. And I'd check it real quick by putting 5.1 in, which makes e to the 1.1. 3 times 2 is 6. And then I'd put a 6 in here and see if it comes out as 5.1. Well, the ln of 3 is 1.1 plus 4. It does come out as 5.1. I'm moving on. All right. I don't care what you square over here. You square something and I hide that, well, I cannot make that 1. Squaring is going to get me positives or 0. So I'm going to make y equals 6. Because if I make y equals 6, then instead of covering up what's on the left, I can cover up what's on the right. And I can see a couple of numbers that work for 6. 6 for y. And that would be 10 squared or negative 10 squared divided by 100 equals 1. Divided by 100 equals 1. What makes 10? 15. What makes negative 10? Negative 5. I'm looking for those numbers. All right, so now I'm going to do the inverse of this, I guess. I guess that's the inverse. And then this was a problem that I forgot to write down, or it didn't print properly. All right, so let's do the inverse, because I can't think of what else I would have asked here. Oh, it equals 7. It's an equation. Oh, let's put the 7 on this side so it looks more normal. There we go. So I'm going to subtract 5. That's 2. I'm going to divide by 4. That's a half. I'm going to do the inverse of exponentiating base 2, which is logging base 2. And I know from our first day of class that that's equal negative 1. And then I'm going to add 3. And I think I get x equals 2. And I'm going to check it to see if it works. 2 minus 3, negative 1. 2 to the negative 1, a half. A half of 4 is 2 plus 5 equals 7. I'm moving on. So f of x is 5x plus 1. I'm hearing I made a careless error on the answer key. I don't doubt it. I did it very quickly. So f of x is 5x plus 1. And I'm doing f of x, really, which is f of x, which is 5x plus 1. And f of x is 5 times x plus 1. So I'm going to drop 5x plus 1 in this parentheses. And I'm going to get 25x plus 25 plus 1 is plus 26. That's what I'm hoping I see. Nope, made a careless error. 5 times 1 is 5 plus 1 is 6. That's what I'm hoping I see on your answer keys. I'm hoping that I can get another marker here that's a little dark. Let's see what I got. Let's see. Oh, this baby's good. All right, so now we're going where? Renee, tell me where we're going. Oh, we're spinning around here. I can't spin around too much. I'll get vertigo. There we go. And let's center that. Bring it up a little closer. And let's do these. Why I asked this, I don't know. I don't know, but I hope people would move the t to the right. All right, and then divide by 8. So t equals 8/7. T equals, where was it? 7/8. So please accept the gift. The ln of 9/2. We're going to learn how to do that with rules of logarithms. The rules of logarithms would have been 2 ln of 3, excuse me, 2 ln of 3 minus ln of 2. Okay, that's what we're going to get. So we're going to get 2.2 minus 0.7. We're going to get an approximation of 1.5. Now let's do it organically. And then we'll see where those rules of logarithms come from. So I'm going to write 9/2 in the E notation. ln is asking for E notation. And that's E to the 1.1, which is 3 squared, over E to the 0.7. Okay, so these are quantities here. And what am I doing with these quantities? I'm dividing. And if I'm dividing, then I'm going to get a subtraction of exponents. What exponents? 2 times 1.1, that's 2 times the ln of 3, minus 0.7, which is the ln of 2. So ln of 9/2 is equal to the ln of e to the 2.2 over e to the 0.7, which is e to the 1.5 approximately. E to the 1.5, and that answer is 1.5, an approximation. That's an exact answer. Okay, putting things in your head here. We'll polish that off in the second half of the term, and you'll do those as easily as you write the equation of a line. Hopefully. So what is ln of e squared times e? Well, I think another way of saying that is e to the 3. And can I find exponents on e that give me e to the 3? I wonder what exponent I put on top of e to get e to the 3. I hope you're saying 3. Word problem. Do I have it in front of me? No, I'll make one up. Johnny puts $200 in a savings account. And it's compound interest. And the interest is, at this point in time, 0.04. And how many years will it take to triple? Well, if I want it to triple, then I want 200e to the 1.1. I think 0.04 t has to equal 1.1. Okay, now a more formal explanation. Let's put it over here so I can get some room there. Now I don't have to push up against the table next to me. 200e to the 0.04, that's the interest rate. T stands for time, and I want it to triple. If I want it to triple, I want $200 to become $600. Now let's solve. I think I can divide 200 into 600 and get 3. I think I can do the inverse of E, which is ln of 3. I think I can undo division by 0.04 as ln of 3 divided by 0.04. And now if I want decimal accuracy, I can rewrite that. I'll come over here with that as the ln of 3, 1.1 divided by 0.04. And if we want to get rid of the decimals, I'll multiply by 100 and by 100. That means I move the decimal 2 places to the right. So that's 110 years divided by 4, which I think 4 goes into 125, so 27.5 years. I believe it's correct. All right, running out of breath, running out of time. Got to finish this right now, right here and now. I'm just going to move the negatives into the other location. So a to the 5 is now in the numerator. A to the minus 8 is in the denominator as positive 8. And 9/15. And now I've got 4. B to the 4, that stays in the numerator. B to the minus 7 joins it. I've explained why in earlier lesson sets. I don't have time to tell you now. 3/5 is reducing that fraction. I see A3, 3 more in the denominator. I see 11 in the numerator. Could be the exact same problem in the same test I've given you, but nobody said it was, so I must have changed just a little bit. All right, so f of x equals this. What am I doing with it? Probably doing the inverse. All right, so what's the inverse? That's what we're doing with it now. All right, so I start with x. I can see subtraction of 4. I can see division by 15. The inverse of 3 to the is log base 3 of. Subtraction of 1 becomes addition of 1. Let's check it by plugging in the number 3. Now let's put 2 in here. 2 minus 1 is 1. That makes it 3 times 15 is 45, plus 4 is 49. In that equation, 2, my short-term memory is so bad, I even forgot the 49. And I had to do the problem again in my head. That means a 49 should kick out a 2, or I got to find my careless error. 45 minus 15 is 3. That's a 1 plus 1 is 2. I'm moving on. All right, square root, -2/9. Name that tune. And it was a square root, and -2 gets me 9. And I can see that 9 to -8 is down. So I got a square root that's doing that and passes through 5, -8. All right, so that's the major operation. I know that -2 gets me 9, so x plus 2 plus 9 gets me my domain restriction and the correct coordinate. How do I get from 9 to -8? Down 17. And how do I get from -2 to 5? Up 7. And sure looks like I'm repeating some problems from the previous test. But they all look alike to me. So I don't know. I do remember that lesson set 21, I think, had an awful lot of templative problems similar to this one. So anyway, I'm done. I'll just say safe and warm. Stay safe and warm. I barely said that properly. 3 videos, got up early, 3 writing the test, writing the answer key. You can see why I'm making careless errors. All right, off we go.